Hello everyone, just a few moments to set up the technical stuff. This is our second online meetup and we are here in Mosaicworks Studios. I am Bolboacă and I will talk today about design principles for microservices, or perhaps a better name would be what is the relationship between all design principles and microservices, or an even better name might be are microservices this architectural paradigm? Is it about what object-oriented programming was supposed to be? So we'll have to look at this for a moment. I'm just waiting a few minutes for my slides to come up so that you can also see them. Okay. All right. So, as I said, I'll be talking about design principles for microservices. For those people who don't know me, well, I've been in this community and I've been a part of this community for a long time. And I've been speaking for a long time in AgileWorks. But in case you don't know me, a few words about myself. I have almost 20 years experience. I'm a polyglot programmer, trainer and coach at Mosaicworks. I'm also a CTO of Mosaicworks. I take care of the infrastructure for various projects that we do. But most of my work is around helping customers, helping programmers, helping teams get better at what they are doing. And recently, part of this work has also been around microservices, since a lot of people adopt microservices now. And many of them adopt them for the hype and not necessarily for the advantages and disadvantages and balancing those. So, I've also recently become a YouTuber. If you go to YouTube and search for our YouTube channel called Think Design Work Smart, you'll find that I do various conversations with people. In the past few weeks, it's been typically people who have been in this industry for longer than I've been alive. So people who have been for 45 years in this industry. And it's always been very interesting to me to learn more about the roots of various practices. So how extreme programming came up, how Agile came up, how we come up with the different design principles that we're using, and so on. And one of these conversations was with Alan Worsbrook. Alan Worsbrook is currently team leader for the designing the JavaScript standard, and he has a very challenging job in doing so. He explained in detail how this is quite difficult to do, given that JavaScript has to work for many people. But before that, like 30 years before that, he was a pioneer of personal computing. He worked for Tektronix. He built at Tektronix, helped build Smalltalk. And this was very interesting because Smalltalk is one of the early programming languages that are around object-oriented programming. This was, at that point, the programming language that did object-oriented programming. And this was very interesting, and we discussed at length what object-oriented programming was useful for. Why did people need this different paradigm, and why did Alan Kay felt the need to come with something new, with a new way of structuring the code. And part of the problem was back then that programs were growing and the existing technology didn't allow them anymore to control very well the complexity of the code. But the second part of it, which was quite interesting, is that you have a specific type of problem. And back then, one of the types of problems they were trying to solve is to implement more simulations. And there are two types of simulations. You have a simulation that is based on math, on mathematical equations. If you think about everything that is, for example, mechanics, everything that is, if you think about a computer game, for example, you have gravity, you have movement, and so on. These are things that are fairly well known and fairly well modeled as equations. But there is a different type of simulation. It's a type of simulation where you don't precisely know a formula to implement in order to make it work. And an example is if you want to model a weather system. So of course, probably today, most weather system simulations are based on statistics. But if you think about it, there can be a way of modeling this, which is you have the wind object, and the wind blows, and this influences the clouds objects, and the clouds object change their own speed and other types of parameters, and this changes the temperature around, and so it starts raining, something like that. And in order to simulate something like that, what you will need is the idea of an object, something that sits around, waits for messages, and when it receives a message that it can do something with, it reacts to it. And based on these reactions, you get a chain of events that happens inside that system that is modeled with objects and messages, entities communicating between each other. And this is a very interesting idea, because when I first saw the idea of microservices, what do we think of microservices? Small entities, should be small, that are running, that are waiting for something to happen to them, and then they react. And one particular way of implementing microservices is by using events, which are equivalent of this idea of messages. So that was very interesting. And if we move further, there's an even wider connection. Alan Kay, who came up with the idea of object-oriented programming, was at some point asked, is the current object-oriented programming what you envisioned? And basically what he said was, not necessarily. Instead, this is what I'm thinking about. And what he said is OP meant messaging, local retention and protection, and hiding of state process, and extreme-late binding of all things. But even more interesting, he said, perhaps every object should have an URL, which is a very weird and uncanny connection with microservices, right? Because if we think again of microservice, it's an URL, you call that URL, send a certain message to it. Nowadays, that message is usually an HTTP request, but nevertheless, it's very similar. So that made me think about older design principles. If these fundamental ideas seem to apply to microservices, could we take other design principles and apply them to microservices as well, and what would we get out of it. And this is not a comprehensive walkthrough through every design principle that you see here, but it's more like an eye-opener for you to look at a few sets of design principles. These are sets of design principles that I have used in modeling my code for different reasons. And I've used 3 different types of sets of design principles: the Unix design principles, the low coupling, high cohesion, or in more general, the GRASP set of design principles, and finally, more recent, although some of them are quite old, the set of solid principles. So let's look at them and see how they apply to microservices, and do they apply to microservices? Can we learn anything from them? The first set of design principles that I learned and I found very interesting is called the Unix design principle. And I like to point people to this link. There's a book, a free book online called The Art of Unix Programming, and part of it, basically 1 page from that book, is about these various rules that people apply, stated in different ways. And these are the rules that the people who have developed Unix-based programs have thought of when designing them. And if you've ever used Linux, you know that you can do a lot of interesting things with the command line. And the reason is that most of these things have been applied to many of the command line tools that we have in Linux. So first one would be rule of modularity, right? Simple parts connected by clean interfaces. Now, when people think about microservices, my fear is, and actually my observation is often, they think of a way of scaling up parts of the performance, so allowing more users to call the same application, or do some kind of separation in the architecture so that they can develop faster the things that are required to develop faster. But what really microservices is about, this architectural style, it's about distributed modular architecture. It's distributed because each of these programs run separately. It's modular, at least if you want to have a good architecture that allows you to move fast and to avoid breaking things when you change a lot of things, and to allow you to make changes easily, then you need very clear modules. And I feel that often the big and most difficult part of microservices is figuring out which are those modules. Incidentally, this happens whether you are doing microservices or not. The hardest part right now in architecture is probably figuring out modules. Then how you deploy them later depends on the operational requirements that you have. But anyway, let's go back to the rule of modularity. What this leads to is, how about we have very simple programs, in our case microservices, that have very clean interfaces and that you can recombine in different ways. And this leads to the second rule of composition. Design programs to be connected to other programs. The rule of composition, this is why we can compose and call long chain of commands in Linux, because the programs are designed to be connected to other programs. And this is the same idea we try to apply for microservices. They need to connect to each other. You have a very small feature in every microservice, but then the connection between them is what makes a bigger program, a more useful program. Rule of separation: separate policy from mechanism, separate interfaces from engines. This is quite a subtle one. What you'll see often in any Linux program, if you look at the structure of a Linux graphical program, you'll often see that it has the graphical interface separate from a library. And that library is kind of the mechanism or the engines of that program. This also allows many of the Linux programs that we have to be used both from command line and from a graphical user interface. How does this apply to microservices? Well, perhaps the way you communicate between microservices should be separate from what you are actually doing inside the microservice. What this means is that you could have an event-based system using a Kafka kind of thing, a message queue, where you pipe in messages, you pipe out messages, you respond to the things that happen. Rule of parsimony: write a big program only when it is clear by demonstration that nothing else will do. This is something I feel we often forget in our normal software development. We jump onto the biggest programs we can write, or we grow them and grow them and grow them until we don't know how to deal with them anymore. In Unix, you think differently. You think, okay, how about we do just a very small thing and don't allow it to grow larger than its purpose. In our case, when we talk about microservices, what that will mean is we have, instead of writing very big kind of monoliths, we split into very small programs, but programs that do just one thing and do it well. Rule of representation: fold knowledge into data, so program logic can be stupid and robust. I feel this is often the key to good microservices, and not only, in general, to good and simple code. I would rather have more complex data and data structure than more complex code, because complex code tends to be very difficult to change and to maintain, and we need to change code fast. When we talk about microservices, once again, this would mean the database for the microservice would have something, the more complex part rather than the code. This also incidentally allows us to write smaller microservices. Rule of extensibility: design for the future because it will be here sooner than you think. Who would have thought about that? The whole idea of microservices is allow us to move faster. The reason why microservices were initially created is, as an architectural style, was to use the Conway's law in the favor of development, in the favor of the speed of development. Instead of fighting the organizational structure, you create the organizational structure along with the architectural style. What this means is that the first teams that did microservices, basically there were some teams who were splitting the small modules, but then those modules, the microservices, were very separate from anything else, and you could pipe them into pairs of developers that worked in parallel. And this allows you to grow to a very large number of developers while managing the complexity, because you are working with Conway's law and not against it. There's one principle that captures kind of the whole philosophy of Unix, which is write programs that do one thing and do it well, write programs to work together, write programs to handle text streams, because that is a universal interface. So what are we doing with microservices? We try to have programs that do one thing and do it well, hopefully, at least if we want to move very fast. We want these programs to work together, and the best way is usually to base the communication on events. We write program to handle HTTP, which is fundamentally a text stream. So you could say again that we have an uncanny similarity. And you see how these different ideas related to design come together into something that seems very, very new. But these ideas are very old. So perhaps all principles apply. Microservices are a new iteration of older ideas, and that's why we would expect to have different types of ideas. The difference is, however, that we move the microservice at a higher level. If we were discussing in the case of Unix about executable programs, about programs that don't necessarily run a very long time, because that was the initial idea. And yes, that might include some services, but I think the initial idea was around the small command line tools. And we'll see in a moment, object-oriented programming was referring at the classes, well, actually at the objects that we write in our code at a very low level. We have now moved at a higher level. We are now looking at a new type of design entity, a microservice. So let's look at a few other ideas related to design, and this time we'll look at object-oriented programming, and we'll start with encapsulation. Can we apply encapsulation to microservices? Well, first of all, I like to remind people, encapsulation is actually two things. One thing is a way to restrict direct access to the object's components. So you don't directly change data inside of an object. You usually go through methods. And of course, there are some exceptions to this rule in case you have data, objects, or entities. But if you have like objects that are doing something, usually you call methods. Second is a language construct that allows you to bundle data with the methods that operate on that data. And this was fundamental, I realized from the conversation with Alan where it broke, that part of the problem back then was that you were writing a bunch of procedures that were working on various types of data, but programmers had no way of identifying which procedures were working with which type of data. So whenever you had to change certain data structures, you would have the problem of breaking a lot of procedures, and it was very hard to do so. So bundling these together made a lot of sense and simplified a lot of the complexity. But if we are now thinking about microservices, what would that mean? Well, once again, we are thinking at a higher level. Each microservice can have its own database. nobody else can access a microservice database, right? We are hiding the data inside the microservice. And there's no actual language mechanism, but you have an API that you are calling. You cannot directly call the database. This is how an encapsulated microservice would work, and this would help us isolate ourselves from changes in the data coming from outside. It allows us to preserve the data in a way that makes sense for our microservice. Now, if we move to the general grasp principles, the first one is low coupling. Low coupling means, once again, just to remind you, the degree of interdependence between software modules. There are actually two ways of thinking about coupling. One way is the coupling surface between two different components. So for example, if I have a user class that has a first name, last name, email, and so on, and if I have another class that is meant to format the name for a user, if I pass in a user object, then the coupling surface becomes the whole user class. If I pass in just the first name and the last name, the coupling surface is reduced. It's only those fields. Another way of thinking about coupling is if you have a class A, a class B, what kind of changes in the class B would provoke changes in class A? And this is kind of more imaginative way. So it's a more dynamic way and a more static way of thinking about coupling. And I kind of use both, but I prefer the dynamic way. So how would we do low coupling for microservices? Well, first of all, very important, do not have microservices call directly other microservices. If you have that, then you have high coupling. The coupling surface has increased, is the whole interface of the called microservice. Second, if you think about the dynamic way, if the second microservice changes, you may have to change the first microservice. So how can you do it differently? Well, you can do, as we were discussing, indirection through an event bus. You have a Kafka, something like that. You send messages in. The microservice does what it's supposed to do. For example, receives a message, create user. And actually, just let me rewind. You pipe a create user message on the event bus. Whoever is in can create a user. Our create user microservice will say, oh, I can do that. We'll create the user and then we'll pipe out another event saying user created, this is the user information, kind of the ID or whatever is needed. So this is the kind of idea where you can completely separate microservices from one another. Of course, whenever we talk about these principles, you need to balance them with some other constraints. For example, if you have a particularly performance needy part of your code, you may have to directly call the microservice. And it's okay to do it from time to time, but it's not okay, most likely. Well, it will create you troubles and it will slow you down if all the microservices call each other. The next one would be high cohesion. The degree to which the elements inside of a module belong together. And let me restate that a microservice is or should be a module, right? So then what is cohesion in this case? The degree to which the elements inside the microservice belong together. By the way, this is a picture from The Last Jedi, and I find it very relevant for cohesion because one of the reasons why this was so surprising was that the character, Luke Skywalker, is not cohesive with his past in this particular scene. And I won't go into that, but actually there are a lot of similarities between developing a TV series or a series like Star Wars with developing software. That's an interesting idea. So you can look at cohesion also on a temporal line in that case. Right. High cohesion for microservices, what would that mean? Typically, it means that you need to have a very small interface, as small as possible, but not smaller, because when you have fewer methods in your API, it's less likely that you have any extra stuff that doesn't make sense, that doesn't fit with the rest of the methods from a microservice. By the way, this is valid for any kind of API. Well, it's a general principle. It's quite obvious. Once again, of course, we can break this principle from time to time. If we have some particularly, again, performance can be a problem. We don't want to have two microservices communicating, even though they don't, their methods, their API methods don't fit with each other, but it's faster if they are in the same module. Sure, as long as it is a conscious decision and you know precisely what you're doing and you're not doing it extensively. And we are moving into the next set of principles, which is the solid principles. And I will not go through all of them, but I will just briefly go through a few. The single responsibility principle. We often think about single responsibility principle as applying to a particular class. However, if you look at the statement of the SRP, it says every module or class should have responsibility over a single part of the functionality provided by the software, and that responsibility should be entirely encapsulated by the class, module, or function. So when we think about single responsibility, we shouldn't think about it only at the level of a class, only at the level of an object. We should also think of it at the level of a module and at the level of a method or function. So how does this apply to microservices? Is basically the same idea that we kind of see appearing from our discussion until now. You should have a very small module that does one thing that is entirely encapsulated. And we've discussed how to encapsulate it. We've discussed that we need to separate modules and to have very clear responsibility. Open-close principle. Once again, very interesting idea that doesn't apply only to classes or only to functions. Software entities, classes, modules, functions should be open for extension but closed for modification. So how would you do that? And one of the ways to do that is to very clearly separate the fundamental, the core responsibility, the core features of a module from the other features of the module. Which in other way, that's why it connects very well with single responsibility. If you have modules that are single responsibility, you have a higher chance that they will also abide by the open-close principle, because they will only encapsulate their particular responsibility. In order to change the way a user is created, you just go into the create user microservice. If you want to change the way a user is displayed, you will not go into create user microservice. However, this allows the behavior or parts of the behavior to be changed by outside forces. Of course, another way to do that that's very used in object-oriented programming is by using dependency injection, which is not something I would particularly recommend for microservices, but the collaboration between different microservices through an event bus could also be seen as a kind of dependency injection. If you have a part of your microservice where you need to create, I don't know, a password or something like this when you create the user, and this gets delegated to another microservice, which then gives you the right information afterwards. You don't care how the password is created, that is separate. You can still create your user. It will work. And it's another way of doing a dependency injection. By the way, many people believe that dependency injection is a framework. Dependency injection is actually a design pattern. So if we apply these design principles, and we can also think about interface aggregation principle, about we discussed open-close principle, we get to a few conclusions. How about we have small microservices with a single goal? Each microservice has its own database, and the microservices, unless they need to do something quite special, communicate through events. That's basically what many people are saying about how microservices can be useful. Now there's an interesting principle that we haven't talked about, and it seems like it wouldn't apply. Liskov substitution principle, which basically says that you should be able to replace any subtype, any parent type with a subtype without altering the desirable properties of the program. One counterexample to that is if you have a rectangle class and you derive from it a square class. It seems like it's the right thing to do if you're starting with object-oriented programming and you have inheritance, you want to use it. However, this breaks the contract, because for a square class, if you change the width, you should also change the height. This is something completely unexpected for a rectangle. So this breaks the contract. It's a very typical Liskov substitution violation. It's not something you should do because it creates surprise in your program, and we don't want surprises. So the question is, can we apply Liskov substitution principles to microservices? So let's look at it, and to look at it, we'll first go a bit through modularity. If you look at this picture, this is the International Space Station. One of the very interesting things about the International Space Station is that it has been built with pieces coming from different countries. How are you able to do that? Well, because you agree on an interface, you agree on a contract. This is what modularity is about. This is a very modular system. And so modularity is the degree to which a system's components may be separated and recombined, often with the benefit of flexibility and variety in use. So fundamentally, when you have small modules, you should be able to recombine them to obtain new features, right? If you have a create user with a way of creating the password, you should also be able to create a user that has only two-factor authentication, or who can authenticate only with a YubiKey, so with passwordless, something like that. This is the kind of recombination that you can do once you have modules. So now the interesting idea is, when I think about risk of substitution principle, I think mostly about how I can replace classes, right? I can substitute a base type with a subtype, things should still work fine. But there's one very interesting thing, and that goes back to my conversation with Alan Worsbrook. The initial idea and Alan Kay's idea of object-oriented programming was very much centered on objects. Classes have appeared later than objects. We first had objects, and then classes appeared as a way to classify, that's why it's called a class, a way to classify different objects that are similar in nature. So if classes are classification of objects and we are moving one step higher, what about having microservices and classes of microservices? And I'm very much surprised right now that until now we don't yet have a way of defining microservices, so some standard APIs for example, create user. And then I could pick from a shell, from the class of create user microservices, I could pick the one that fits my operational needs better. So maybe there's one that uses Active Directory, maybe there's one that uses a MySQL database, maybe that's one that uses an in-memory database, and so on and so forth. And they have different curves for the various operational parameters. So for example, they can scale to a number of users, or they can, the cost varies in a different way if you are deploying it to a cloud system, and so on and so forth. And this would be the idea, that to bring the microservices to be at the level of, object-oriented programming for architecture. So basically what we have been doing in an image is and software development is about moving in a spiral. This industry has started from a few ideas, and then we kind of recycled those ideas again and again and again. And if you want a different lesson from this, even if you are not interested particularly in the microservices architectural style, a lesson would be, look at our past. Look at the ideas that have been around for 30 or 40 years, because strangely enough, they tend to come up again and again and again. And with this, this has been my talk. I'd like to thank you a lot for participating. And I will be waiting for questions. Just know that I am on a 30-second delay. So it might take 30 seconds from the moment you post your questions to the moment I can actually see them. So I see that we have a few, sorry. Okay, we have a few voted questions, and I'm gonna go with each of them. So first question, Hi Alex, what are your thoughts on Uber moving out from microservices to macroservices? Now, I have to tell you, one of the challenges with learning more about this architectural style is that you need it for very large projects. And when you need things for very large projects, you typically don't have access to the code and to the architecture diagrams. And even if we work with clients who are doing this style of microservices, we are bound by confidentiality not to discuss them too much. So that's one big challenge, and it has been a challenge for also getting a better idea about how to structure this. So in case of Uber, the only thing I saw is that, yes, they are moving out from microservices to macroservices. And then the next thing that I saw was Martin Fowler, who wrote the article about the defined microservices, saying, we wrote an article about microservices a long time ago. We never mentioned size. And I highly advise you to read that article because if you are interested in microservices, because it captures the important elements. So it captures the idea of a module, the idea of separate, let's say if I remember the exact words, I think it's independent deployment, the ability to deploy independently, and so on. There are a few characteristics, and that has been a problem with microservices from the very beginning. We call them microservices to contrast them with SOA, service-oriented architecture, because they were smaller. But the fundamental idea was a module, and it doesn't have to be a extremely small module. It just has to be small or large enough to give you the functionality that you need as a module and the recombination capability that you need from the different modules. So these are my thoughts. In a nutshell, I don't believe it's a big change. They probably went through a process of separating into very small microservices. They realized it's a nightmare to do the operational part of it. And then they decided to reduce some of that complexity and figured out which is the right size for them, which doesn't necessarily make them a micro or macro or service-oriented thing. It probably gets them to modules that are better suited for what they need, which is, in general, it's a good thing. What is more difficult is that in architecture, you often don't know which are the good or the best solutions, and you have to make a decision, move with it, look at the results, and then learn from it, especially with an architectural style that is relatively new. That's why the fundamental idea is basically caution. Have caution when you are when you are moving into this architectural style. Move quickly, but then also quickly look at the things that you are doing and try to adjust. That's kind of what I have to say. Regarding the rules of composition, what do you think of GraphQL and Prisma if you are familiar with them? Seems like a good way to call and compose microservices. A single endpoint calling everything. Does this apply? GraphQL is an interesting technology, but I have a few issues with it. One issue is that it tends to bind to the data very closely. And this has been a problem. So it's a way of coupling. It's basically breaking encapsulation. So it's a way of coupling the interface with the implementation, which is something I notice developers don't often think about, but it can be a big problem. If you couple a lot the interface with the implementation, you don't have the choice of changing things just in the implementation. So my general, at least, and I'm not an expert in GraphQL, I'm not an expert in Prisma. I actually don't know Prisma. But from what I've seen related to GraphQL, I would advise a lot of caution. It's very useful to do fast development, to prototype things, to get fast feedback. Very, very useful for that. It probably works perfectly fine for this kind of thing. But the situation for microservices is usually we have this huge project we need to develop, right? A huge, Amazon, or I'm exaggerating a bit, but let's say we want to be a competition to Amazon. In order to do that, we need to move very fast. We need to develop in parallel. We need to separate into teams. We need to architect things and have quite a good idea of actually have a way of changing fast. And I'm sure you can use GraphQL in a good way without binding it to the data, but that would be my advice. Be wary of binding it with data directly, unless you are doing prototyping, in which case, sure, no worries. How much a backend is microservices if its microservices are exposed via GraphQL gateway? I'm not certain I understand the question. Yeah, so as I said, GraphQL has this thing of doing too strong a coupling. If you figure out to do lower coupling, that would be something I would look at. But other than that, unfortunately, I'm not sure if I can answer. Does the encapsulation also apply to storage, like file storage? As an example, I have a microservice that uploads a file and stores it for a later retrieval, and a microservice that will do some processing on that file. I find it easier to pass the storage link rather than the entire file. Is there a best practice for this? It's an interesting problem. Now, one way to do that would be you have a microservice that uploads the file, and then the file gets at some point synchronized with the data in the other part of the system where you can then process the file. This happens in case this can happen in case well, actually, this can help you with certain things, but make others worse. So what I see, let me go back a bit. What I see as a problem here is that you are breaking encapsulation, right? And once again, none of these principles is like a law. You should never break it or you'll be punished. All these principles want to guide us in a direction that allows us to move faster, make changes better, and so on. So what can happen that will break this kind of thing? If all your file is doing, all your microservice is doing is uploading files and giving access to files through a clear interface, there's not many reasons to change this kind of microservice. So perhaps you are fine. The other option, if you have the so if you know, for example, that you might need to change this microservice that uploads and so on and offers access to the files, to the storage, if you need to change it in any way, it's useful to make this exercise and figure out what would be a reason to change this. And would this break the other microservice? Would I need to make this, completely or even more decoupled than it already is? So as you see, no decision is easy in architecture. And I would be wary of, I'm never talking about best practices when I talk about architecture. And the reason is that we are usually in a domain where we don't have all the information, but we need to make a decision today. And that's why you almost never have best practice. You have a prototype, you figure out if it's working or not, you figure out whether it's according to your needs or not. And then you learn at some point that there's some breaking change from somebody who needs another feature. And that's the life. Yeah, so I would think about, there's this option, there's the option of synchronizing the files. And of course, there's the option of passing the file through an event system. Now, depending on your performance and scalability, are those big files? If those are 2 gigabytes files, probably you don't want to copy them a lot. If those are 10K files, probably not a big problem. Yeah. When using an event bus, if the structure of the message changes, you still need to write some code to be able to adjust inside your microservice. Isn't this still a kind of coupling? Yes, because so here's the thing. Messages, there's always a coupling between the interface and the implementation. It's good to have as low a coupling as possible, but usually it's stronger than between other types of elements. And the way, at least one team, which was very interesting, the way they dealt with that was run microservices side by side. So you have V1 of this microservice, which still receives the old style message. And you have V2 of this microservice, which you are writing or you can rewrite it from scratch or you can modify it, but you deploy it as a separate one. And you have message V1, message V2. And for a while you send message V1, but then you start switching to message V2. And that's how you make the change easier. Ideally, you try to separate your messages from the implementation, and the way to do that, one way to do that would be to define the API in a very descriptive and as completely as possible. If we are talking about APIs for this style of microservices that send and receive events, their API is basically what types of events I can receive, what types of events I send. And these are, you can define them beforehand, and whatever change you are making, you can make it with a side-by-side versioning. It's not ideal, right? Nothing is ideal in this world that we are talking about, but it is one way of dealing with change and allowing you to change fast. Because the alternate way is I'm changing the message and now I've broken 20 microservices and I need to change all the 20 microservices and so on. And that's not the best idea. I see a comment, yes, but for that you need to support 2 buses. I don't think so. What you need to do is to version your microservice and your message, and the microservice version 1 will only read the message version 1. Microservice version 2 will only read message version 2, right? I'm pretty sure you can do this in a technical way. Okay, I'm scrolling a bit up. There's more I voted. For event bus, would you recommend Kafka over AMQP, RabbitMQ? What do you think about orchestration versus choreography patterns? Oh boy, this is like a very large question. I don't have a particular preference for Kafka or RabbitMQ. What I know is that Kafka has been used for a very large number of messages that work very quickly. So it's basically about sizing your operational needs. What operational needs do you have? How many messages do you expect to send? And then pick the tool that best fits the number of messages that you need to reply to, and also how fast you need to read and write them, and then make tests. So try to, I'm sure there are some performance tests for that, but also make your own tests with some realistic thing. That's what I advise always. Whenever you have a choice between two different tools at this level, which is fundamentally important that it works, that it doesn't lose messages, that it doesn't stop, that it scales up as much as you need, that it works as fast as you need. Always stress test it. That's the best I can do. By the way, in the project I was talking about, which is one of the few case studies that are public and that we know about, where they split into pairs of programmers, and they kind of gave them each the specification for their microservice, and they had no idea what everybody else was doing. They picked Kafka, but they did something interesting. So they had kind of the a very large bandwidth. So they had basically multiple message queues. One of them was very large, where a lot of microservices were putting data into. But then there were some smaller ones that were limited to the subdomains of the domain. And in that case, you can optimize parts of the of your messaging if you know that some microservices are just 3, 4, 5, a cluster of them are communicating together because they are part of a subdomain. Then you can, or part of a domain context, you can have them there. Right? You don't have to pipe all the messages to the top or to the same pipeline. Might not be related to this talk, but what are your thoughts on learning Smalltalk to truly experience pure object-oriented programming? I often thought about that, but I haven't actually tried to look at Smalltalk. I find that Smalltalk is, the concepts are extremely interesting, but by now the technology is a bit difficult to set up and to get into and to truly understand what you can do with it. For example, one of the things that you can do in Smalltalk is it has a virtual machine. It invented virtual machines for programs. But in that virtual machine, you can get in and change some values. So you could change everything that's true with false, for example. And these are things that are very powerful, that are part of Smalltalk, because Smalltalk is also this virtual machine, but it's kind of separated from object-oriented programming. What I would advise you, though, there's a simple exercise you can make, and that we've done at code retreats. And the exercise goes like this. Pick a problem. Usually we use Conway's Game of Life, but you can pick something else. Try to implement it, and but with one constraint. You are not allowed to directly call from a class to another. You have to pass through a class that you create that simulates an event bus. And it's fairly easy to write an event bus for yourself in almost any programming language. And try to see how this changes your design. This will take you to a place where you don't have direct calls anymore. You just send messages, receive messages, and by the way, this is also a very good way to learn microservices with a very low scale experiment. And so this is something I would advise you to try, and it's much easier to do than set up Smalltalk, figure out the documentation, learn the syntax, and so on. Now, if you have somebody you can pair with who already knows Smalltalk, by all means, that's easy. But to learn by yourself, it won't be as easy. Okay. Another question, not sure how related this is. I like your humor. Cool. So we are out of questions. I think we are out of time. So I will switch back to Claudia. Thank you all for participating. I hope to see you soon. By the way, we are organizing something very, very cool. Online conference, AgileTalks conference on software craft. So if you want to learn more about practicing, about how to grow your skills as a programmer, about how to structure your code in different ways, it will be an online conference. It will be on Crowdcast as well. You can see information and buy tickets on craft.agitalksconf.com. Thank you all and see you soon.